We're going to continue on with chapter 13, and we're taking a look at our renewable energy sources. What we'll focus on today is biomass and water. Now, biomass is a type of renewable energy that comes from living things. So that biomass really means amounts of living stuff. So our primary types are wood, using different types of crops, such as corn or alcohol-based fuels, garbage, or landfill gas. Now these two might seem a little bit weird to be putting here, but when you think about it, it's humans that make garbage, and so that's coming from us as living things. Now plant material is probably the most common energy source still worldwide when you think about all the developing nations that might be using wood as fuel for heating their house or cooking. So plant material can be burned as a fuel source. Now, one of the things about using plant material is it does create carbon dioxide as a waste. But I do want to take this moment here to talk about the difference between old carbon and new carbon. We've already learned that carbon dioxide is a primary concern of burning things like with coal and oil. But that carbon has been sequestered for millions upon millions of years. This was plant material that absorbed it, has been buried and sequestered for a very, very long time. Trees that we cut down and use for fuel now are part of what we call the new carbon cycle. It is an active cycle of photosynthesis and cellular respiration. So they are taking carbon dioxide in, they are also excreting carbon dioxide when their cells go through cellular respiration. But they're taking carbon in and they're storing it or sequestering it in their tissues. So when we burn wood, we do release that carbon dioxide, but it is carbon dioxide that has recently been taken out of the atmosphere. So it's not seen as negative as the carbon that's released from fossil fuels, because that does not currently have in place something that just recently took that out of the atmosphere. So it's a net increase in carbon dioxide when we use fossil fuels rather than using this new carbon cycle. Another type of biomass that's used primarily in developing countries is animal waste. You can just straight up burn poo, and that does create an energy source. Now, I've never tried it, but I've heard it doesn't smell too bad, but you do need a lot of poo to make some power go. Now, things that are getting more and more attention are things like biofuels and biodiesel. So these are taking crops and converting them into some type of energy. Now, a lot of you guys probably use gasoline that has ethanol in it. Now, that ethanol typically is an alcohol-based fuel that we get from corn or sugarcane. So here in the United States, based on our climate, our fuel is primarily corn. Now, places like Brazil, a little bit more tropical, they use sugarcane, and this is now one of their primary sources of energy is a sugarcane-based ethanol fuel. So we call those biofuels. Now, when you have flex fuel, sometimes your cars might say it can run on flex fuel. It can run on up to 85% of ethanol. So what this does is it helps to reduce the amount of fossil fuels that are going in our gasoline and substituting it with a renewable source of energy. Now, something else is biodiesel. So this is getting oil from plants. So we can extract oil from things like soybean, palm, or algae. Now, algae is starting to get more and more attention because that has no land use. So we can raise algae in the ocean. So that's going to help to reduce some of the impacts of farming. Because remember, when you farm for corn or sugarcane or soybean or palm, you're going to have all the impacts that agriculture has on the environment. And that's going to take away the positives of switching to alternative sources of fuel. Now finally, landfills and trash, we can get energy from that in two ways. Now here in Fairfax County, we actually burn our garbage. So on trash day, when you put your trash out, it gets collected and gets taken to a waste to energy plant down near Lorton. So we take all of our trash, we put it into a boiler, that's our heat source. We use that heat to boil water, to spin a turbine, that's connected to a generator to make electricity. So we are burning our trash as our fuel source for energy. Now this is a positive because where our trash used to go is just to a landfill. And now instead of all of our trash, it's just the ash. And it does help to reduce the volume of trash by 90%. So it is a significant reduction in the volume of trash, but there still is the ash that has to get put in a landfill. Now, other counties or states that may not have enough trash or may not have the plants to be able to burn your trash, they'll have just a regular landfill. And when you bury trash in a landfill, you're creating anaerobic conditions. And what happens there is the trash slowly decomposes in anaerobic conditions. It creates methane. Methane is natural gas. It's CH4. So if you can find a way to capture that methane, you can at least use it to run the electricity needed for your plant. So this is a great way of taking a look at, say, cogeneration, when that methane could be burned off as a waste product, but instead it can be captured and used as an actual energy source. Now, our pros and cons of biomass. It is abundant, particularly if you're talking about something like trash, and it should be renewable. Where you can run into problems with non-renewable if you are using wood or agriculture. Like we see with trash, it can reduce waste products by about 90%, so that's a real bonus. But the disadvantages, it does result in air pollution. Carbon dioxide, carbon monoxide, NOx, particulate matter. When you burn these fuels, it does create air pollution. It may not be cost effective, which is one of the big reasons why not everywhere burns their trash. You need a lot of trash. So a smaller state, a smaller county may not be able to burn their trash like we do. And when you put ethanol into your car, it does reduce your gas mileage, which might mean you need more gas. Now, water is a potential energy source that is renewable. And we do have some large-scale types of water. So here's an overall view of a dam. So you have a dam, say on a river, and here this water storage, that would be potential energy. As you allow that water to move through the penstock, that's your kinetic energy. Here you're spinning a turbine, that's mechanical. It's connected to a generator, and that's where you get your electricity. Okay, so here it's a very similar process of creating electricity. We're just skipping those steps of heating water. So here is a video that talks about how a dam works.
Green or renewable energy is generated from natural sources such as wind, water, sunlight, rain, and geothermal heat. One of them is hydroelectricity, which uses water as a source and is generated in hydropower plants. Today, hydroelectricity produces approximately 24% of the world's electrical energy. In this video, we will learn how hydroelectricity is produced. The 6 main components of hydropower plants are dams, gates, penstock, turbine, AC generator, and transformer. Dams are built to hold back water, which means a large water reservoir. As the gates are opened, a small opening of a large reservoir builds very high water pressure as it flows through the penstock. Penstock is a pipeline that leads to the turbine. It is designed in such a way that the gravitational force pulls the water down to the turbine, which produces kinetic energy. Turbines consist of large fan blades and a spindle. The spindle rotates when the water strikes the blades, thus converting kinetic energy to mechanical energy. On the top, there's an exciter, which gets small DC power. Below the exciter is the generator. The working of an AC...
Okay, I stopped the video because it's going to get into the inner workings of the generator, which we just don't need to know. So the basics are that you have potential energy behind the dam. As the water flows through, that's kinetic energy. It turns a turbine, that's our mechanical energy, and then it's converted to electrical energy in a generator. Now, this is the primary way that we use water to get electricity, is with dams. Now, one of the problems with these dams is pretty much any river that can be dammed, we have dammed. So the future of this as an energy source is limited because we've already done such a good job with it. But one thing that we haven't really quite tapped into is the power of the ocean. So one big thing that we can look at with the ocean is wave power. So this is going to show you a basic of one way. There's other ways we can do this, but this is one way that you can use waves as a perpetual source of energy.
The water of the oceans of the world is almost always in motion. Hardly ever interrupted, waves break at the coastlines, sometimes strong, sometimes weaker. There is an enormous energy potential that is available round the clock and free of charge. A potential that, if fully exploited, could satisfy 40% of the worldwide demand for power. This equals the output of 700 to 800 nuclear power stations. Foyt Hydro Wave Gen is developing technologies to convert this inexhaustible energy into electric power without the emission of harmful greenhouse gases. The operating principle of this wave power station is as simple as it is ingenious. An enclosed chamber has an opening beneath sea level, which allows water to flow from the sea to the chamber and back. The water level in the chamber rises and falls with the rhythm of the waves, and air is forced forwards and backwards through the turbine, connected to an upper opening in the chamber. As it is compressed and decompressed, the airflow has sufficient power to drive the Wells turbine. It is a feature of the Wells turbine, named after its inventor, that it is driven in the same direction by both forward and reverse airflow through the turbine. Even relatively low wave motions can generate enough airflow to keep the turbine moving and to generate energy. This is how easily energy can be generated with a wave power station, day and night, all year round, as long as there are waves. The world's first power station of this kind was put in service as early as November 2000 on the Scottish island of Islay and has been feeding power to the grid ever since. Foyt Hydro Wave Gen is convinced of the commercial potential of wave energy. We are certain that our wave power stations can make a significant contribution to supplying the world with climate-friendly energy.
Okay, so that's one way. So notice again, it's just finding a way to turn a turbine that allows that to be connected to a generator to create electricity. There are other ways by using that up and down motion, by connecting that to a turbine that can go vertically up and down with the waves. So there are several ways that we can use the power of the waves to make energy. So our pros and cons of water. One big pro is that it's abundant and it's clean. And again, here with this clean, please note that I mean no SOx, no NOx, no particulate matter. So the use of this water power does not create air pollutants. Do you remember all the pros of our dams? That it creates a reservoir for water, that it can allow for irrigation, that it can be used for recreation, that it can control downstream flooding. All those pros stand. But our disadvantage are all the cons of dams. That it's harmful to fish. It blocks the pathway of fish. Just making sure I'm catching that last bullet. That it can cause upstream flooding. And remember that you might have to make those fish ladders. And that as water comes out of the dam, it comes out at a pretty high pressure. And those bubbles can get into the bloodstream of fish and cause problems very similar to the bends of scuba divers. So pretty much with water, it's all the pros and cons of our dams, because that's our primary way that we get water. So we will fill out a graphic organizer for both biomass and water, so that we have how it works and our pros and our cons all in one place.